Okay, welcome everybody. Welcome to this session on running containerized applications on Azure Container Services using Kubernetes or Docker Swarm. My name is Marcel de Vries and I'm the CTO of Expert in the Netherlands. You might already have heard I have a little bit of a funny accent, but that has to do with the fact that I'm traveling half of the world just to get here and do this session. So before we get started, I want to start with what is the problem that we're actually trying to solve when we talk about all these fancy things like Azure Container Services, containers, and all that other stuff. Because sometimes it's just cool to do tech, but I think it's important to understand why are we doing all these things and what will actually contribute it to the stuff that we do on a daily basis. So to get started with that, I thought, what about if you would, for example, have a cool game and you would like to share it with someone else? Can you imagine that you just came across this awesome game, you thought, oh, I would like to share that with my friends. And when you want to share it with your friends, then you say, okay, I have this great application. The only thing you need to do is you install Linux on your machine. After you've installed Linux, then you install a web server. And after you've installed the web server, you open this firewall port. And you need to get these additional packages with apt-get. And after you have these packages, then we need to do some additional yak shaving to get things going because there might be some route not configured in your firewall or whatever. And then after 2 hours, it's just time to cry. Because you just wanted to play the game instead of just doing all that techie stuff before you could get started. Now, what if there would be a different way of sharing this amongst your friends in a very easy and simple way? And for that to happen, let me get to the following demo. So what I will do is I have on my machine Docker. And what I will do is I will switch just for a second to Linux containers. Because on Windows, we can do both. We can run Linux containers and we can run Windows containers. I just had it switched to Windows, and now I need to run it on Linux. So if I would get my machine back, that would be great. So if all's well, it's switched now to that particular Linux environment. And what I should be able to do now is go here and say, OK, let me run this command line. I just run this command line, which is nothing more than docker run, providing a mapping of some ports, and I will get to that a little bit later, and just start this image that I have. And once I started it, which was pretty fast, I can now go to my machine, go to localhost, if I could type, and all of a sudden, we have this cool game. So there's a very easy way, of course, to share among friends. And we can now play Mario Brothers if we want to. Okay? So it's actually working. You can just run around here in this maze. And it's, you see, I'm not good at playing games. But anyway, just to get the point across. So it's very easy to share these things amongst each other without doing all that hard work. That hard work has been done for you already by the virtue of the fact that we now have an image. So for my other demos, I will switch back to Windows containers. So that will bake just in the background. So what if we could make that happen like this? I mean, isn't that a much better way of sharing stuff amongst each other? This is more like, OK, this is very easy. That's a very good way of sharing stuff. But then the question, of course, is, but how do you make this work? How are we going to make this work, not only for our games, but preferably, of course, for our business applications? Because we've all seen the fact that we are able to build code, but then it needs to go to a dev environment, a test environment, acceptance environment, and then finally we go to production. And all that time, we need to install that software, do all the yak shaving to get things running, and then finally we can go to production and probably make mistakes while doing so. So the technology behind all of this is what we call containers, and containers work as follows. So the idea is that we have the infrastructure layer, so just our standard infrastructure, a Windows PC or a Linux PC or just a machine. We run an operating system on top of that, and on top of that operating system, or that operating system has a capability called containers. Now, what we can do all of a sudden, we can then containerize our application and run that container on that machine in complete isolation of any other container that runs on our machine. Now, the fun thing about a container is that it contains our application plus all its references to other stuff, meaning that it makes it very easy for us to have multiple of these things running on our machine without polluting each other or, more or less hitting each other and bumping into each other and making things broken. So what we have is a different way of virtualization than you normally have when you would do virtual machines. Because with virtual machines, we have this notion of hardware virtualization, but with containers, we have the notion of kernel level or operating system virtualization, meaning that we do not need to run a second operating system on our machine, but we can just leverage the operating system that's already running. Now, what's important to understand is that if you create such an image, then your image becomes dependent on the kernel on which you build it, because you can imagine that if you have a new version of a kernel, that, you're sharing something, you are using something that's part of the operating system, which is not virtualized. Well, it's contained, but not virtualized. So that's the way you can run containers on a Linux machine. And the fun thing is no additional overhead with additional operating systems. Now, if we go further and look at Windows containers, then it's more or less the same. We have this infrastructure. On top of the infrastructure, we have the Windows host operating system. And on top of that, we can run containers. So this is just a containerized application, which is a Windows Server container. Now, the Windows Server container is exactly the same as this Linux Server container, only the thing is that the container image that I created now has a dependency on the Windows operating system. So you can imagine that you cannot run a Windows container on Linux or a Linux container on Windows. There are some exceptions to that rule, but I will get to that a little bit later. So similar as Linux, but now on Windows. Now, on Windows, they added the capability of running these containers in a little bit more of isolation, because you can imagine that if there would be something like a kernel exploit, then these containers might be able all of a sudden to talk to each other if there's something wrong in the operating system. So what they've done is said, well, we create this very thin hypervisor or this very thin operating system layer that will boot on my machine, but then we run the apps in that Hyper-V container, giving us more isolation than we normally have if we just run the containers on the bare operating system. Now, because it gives us better isolation, it also gives us an additional opportunity. And the additional opportunity is that we can now also say, well, what if we could have an optimized Linux hypervisor operating system and then run Linux containers on top of that? Now, the fun thing is that Hyper-V Linux containers are now also part of Windows as part of Redstone 4. So which is now, what do they call it? The Spring Creators Update, I think. So if you have that running on your machine, you can now run Linux containers and Windows containers also side by side, which is kind of cool. Now, Microsoft also integrated the container management infrastructure in there. They created an abstraction in there that they can use the Docker engine, but they could also easily swap that out for any other container manager that might be out there, because they abstracted the compute layers in there. So if you look at a container, then the container runs an image. And an image contains several layers. So a container image is immutable, meaning that once you create it, you cannot change it. You can only add layers to it. And a layer can, of course, delete a file and then add another file. But that is constantly stacking on top of each other. Okay? There's no way to change an underlying layer. So that's important to understand. And then the container itself is nothing more than a very thin read-write layer that you create that all of a sudden can write again to, you might say, that image. And then based on the stuff that it will do, we can either commit that to a new image or discard it and throw it away. Now, on top of that, we have container tooling. And when we talk with people about containers, then people are always talking about Docker. But Docker is something different than containers. Docker is the management software that you're using to work with containers. Containers are an integral part of your operating system, and you have this management software on top of that, which is Docker. Docker was the first one to standardize this notion of containers in Linux, and they expanded that together with Microsoft on the Windows platform. So we use Docker as a tool on our machine to interact with the containers and do all kinds of cool stuff. So for that, we have the CLI, a command line interface. So just as you saw me type Docker run, I can type many different commands to work and manipulate running containers, creating images, committing images, pushing images to registries, and all that other stuff. Now, if you would like to build an image, you create this notion of a Docker file. And I'm not going through all the sentences here in this Docker file, but a Docker file contains the statements on the layers that you want to create, and then you can commit that to an image. You can share that image with others. And then the only command you use is docker build. You provided a tag, which is the name of the container, container image you want to create. Then from that moment on, you can use it by that name and create an instance of that. Now, let me show you how that's done to give you a good understanding on what containers can do for you. So if I go to Docker and I do PS, then you can see that I have some containers running on my machine. Don't bother looking at them further. But this is a command on seeing what are the running containers. There's also a Docker ps-a, which also shows me the containers that are not running anymore. Now, in this particular case, they're all running, so I keep with that. And what I would like to do is do a Docker run. I would like to do that interactive, so I can interact with the container. That's just a terminal connection between the container that runs and my my command prompt over here. I would like to run the Microsoft Windows Server Core. I would like to run the command line. Okay. It does not exist. Can I type Windows Server Core? Microsoft/Windows Server. Oh, yep, there you go. Thank you. Thank you so much. What it will do is it will go look at the images that are on my machine. If it cannot find it, it will go off to the internet and then pull it from some secret location that we get to in just a second. And now it's starting up this container on my machine. Since I'm running Windows 10, the default isolation mode is an Hyper-V container because I'm running Windows Server images on my client operating system. Okay, so I'm always using the Hyper-V version. Now, if I do a dir here, you can see that I get a standard operating system, nothing fancy in there. It's just a clean OS, nothing on there. What I could do is I could do say something like make directory demo, cd demo, create a file here, copy con myfile.txt, and then some old-fashioned command to write text to a file. And then Control-C and it writes it down. So if I now do a type command, I should be able to see what is in that file. Now, what I did is I created new state. This is the thin read-write layer on top of my image. And now I would like to exit this container. Now, be aware of the fact that the moment I exit this container, the container was started with the command line. The moment the command line is done, the container is gone. Okay, so it's then stopped automatically. If I do a docker ps, you will see that the container is not there. If I do a docker ps-a, you will see that it's there, and that I now have this Windows Server Core over here, which I did not have previously. This is a container that has died, but still has some residue left in terms of state, but that state is not captured yet. Because if I would run Windows Server Core command again, what you will see what happens is that I get a complete clean environment again. Remember, containers are immutable. Or I should say the container image is immutable. So that means that the moment I terminal into that container again, we will see that that demo folder that I created will not be there. So if I do a dir here, that would be dirt, but dir. You see that the directory is gone. Now this makes total sense because they created a new instance, like a class and an object. You have like an image, you create an instance of the container, and you get a new fresh one. Okay, makes sense? So now what I can do is I can do a docker ps, -a. I see that I have the old one there. I can remove these residues. So I can say docker remove, and I could remove 7.4. I just need to give enough information to clean that particular one out. So this is the way we can interact with containers, create new instances of containers, and build your own containers as well by committing the state that we already have to an image. Question? Yeah. So the question is, why does it make sense that the container is in a like dead state, still on your machine, and that the residue is still there? Because it gives you the option to do the following. Let me show you that right away. So what I can do, if I do a docker ps -a, I can see the died container, which is identified by F7, right? And I can do a docker commit. I do the docker commit on F7, and I give it a tag, Marcel V, demo container, demo image. I will just commit it. This. And then what I can do is do a docker images. And you will see that there is now an image with no name. So what I created is a new image based on the older state that's there. So it gives me the option to capture that state as a new base image to run off from. Okay, because now I can do a docker run minus IT of CF, which is the image identifier. Run a command on that, CMD. And now if I would go into that container again, because it now creates an instance of that older image that I just committed to disk, now all of a sudden I should be able to see my demo folder again in the text file. Make sense? Okay. So while you're working with Docker and do this a lot, you will see that you leave these little tards around on your machine because you never clean them up. So that can become a very long list of all kinds of stuff that you never wanted to commit to. Okay. So if I do a dir here, you see now that I have my demo folder again, cd demo, and type my text file, and there it is. Okay, so that's the way I can now leverage that thing. I could now create some delta on top of that, commit that again, and that's the way you create more or less these images. So you always start with a base layer, and on top of that you install stuff. For example, you enable a Windows Server feature like ASP.NET or .NET framework, and then that would be committed to an image, and then you can say, and that's what Microsoft does, you say, well, this is the new ASP.NET image that you can use. And then you do not have to create those layers anymore. They're created for you. Yep. Okay. Now the big question is, I had these images on my machine, but where do they actually come from? Because we do not want to create these images ourselves all the time, and they need to come from someplace. So containers come from what we call a container registry. We can have different registries. We can have public registries and we can have private registries, which makes a lot of sense because if I work for a bank, I probably don't want to have my trading algorithm all of a sudden in the open that everybody can use. So I want to have a private registry and, of course, a way to log into that registry and then actually pull those images down. Now, Docker provides this notion of Docker Hub, where you can get all these base images from. Microsoft publishes their base images to the Docker Hub. You go to hub.docker.com and you create an account. You can then log in there and get all the public images, by the way, without even logging in. So you can do, for example, Docker pull, and then you pull Microsoft / Windows Server Core, and it will pull down that particular image. Okay, and it will then lay it down on your machine, and from that moment on, you do not need the registry all the time. If you create a command and ask for a specific image that it doesn't know, it will search automatically and pull automatically. Okay, that's the way you interact with these registries. Now, Microsoft provides in their cloud also a registry which is geo-replicated, which is kind of interesting because what we have is we have perhaps our data center, and our data center might be connected to Azure using ExpressRoute, and I want to run my containers in my Azure cloud. Now, it makes total sense then to have an Azure container registry instead of the Docker registry, because then I can pull it from my own private location inside that same network, which makes it much more efficient. Now, if I have a distributed environment in my organization and I want to have an image here in Minnesota, but also here in the Netherlands, then I can just select, oh, I would like to replicate that to West Europe, and it will be in Amsterdam as well. And that replication is done for you, so the pull then is to the local data center that you might run your Windows Server machine to pull that image, or your Linux machine to pull that image. And then you do not have to pay for all the bandwidth for the geo-replication. Now, Azure Container Registry is nothing more than in the Azure portal, clicking here on Container Registries and then say, I would like to have another one. Okay, I can just create a demo NDC container registry here, use existing something like NDC. so I can clean it up. And then you see that I can enable administrative user. And when I select the premium tier, that's the moment I get the ability to replicate across the globe. Okay. I will not touch create at the moment, otherwise I need to clean it up again. And it's just saved me some time later. But I already have a registry created over here. And what you can see is that you then can see in a registry, you have these repositories. And that's where I publish my images to. So what I could do is I could log into, for example, Docker Hub and push my image to Docker, or log into my ACR registry over here and then push my image to there. It's nothing more than Docker login, Docker push, and then name the image. Okay, and that's it, and then it's up there, and then anybody can pull it down from there. And I will show you later, you know, what a little bigger demo on how you actually use that. So now we're on a single machine and we have a container, which is nice. We have some local images, but if you see applications, then you will probably not work with just one single container. You can imagine that you have all kinds of dependencies. You might want to have something with a database, and you want to run a database on your local machine. Now, one of the difficulties as a developer has been, for me at least, that I always need to install all that software on my machine. Wouldn't it be great if I could just do a Docker pull of a SQL server and then run that SQL server locally, and then instead of just starting my web app, have that web app use an environment variable that it knows to go local and then connect to my local instance of that container. And all of a sudden, every developer can just do nothing more than Docker compose up, giving a specific format that I will go into a little bit more detail. And all of a sudden, it will pull down all the stuff from the registries and it runs on this machine. And you can debug it locally. So all of a sudden, there's no setup anymore of your local machines. The only thing you need to do is have just your Docker compose file in your Git repository and then pull that down, run a Docker compose on that, and you will get instantly something that's running on your machine, even using a SQL database, a Redis cache, any other stuff you can name, Nginx, you name it, it's there already. So what you will do is you will normally compose your applications out of multiple containers, not just one. Of course, you could stuff everything in there as one thing, but it makes more sense to make these little piecemeal things so that it's easier to swap things out and then select different things for different environments. For example, the database, it's okay to run it in a container on my local dev box. It's okay to run it in a container on my test environment. But once I go to production, I want to go to my standard SQL Server failover cluster that's running there without touching that with a container, for example. So Docker Compose uses a Docker Compose YAML file, and YAML files are space sensitive, so you need to have 2 spaces or multiple spaces between different things. And here you see a definition of a version 3 format where you see that we list out the services, and a service you can see is one running container. And that service can then be, for example, dependent on another service. And the moment we do a Docker Compose up, that's the moment that the Docker engine will figure out for you how the dependencies are, and it will start the right dependencies first, and then it will actually roll up to the top-level service that's dependent on all the other stuff. We can pass in environment variables. We can pass in port mappings so that we can, for example, map something that is running in an Internet Information Server on port 80 to port 8080 on my local host, and then connect to that. Okay, that's a very easy way to just map something which is always just running on port 80 and then mapping it to a port that I would like to use. Now, if you look at Docker Compose of these services, then you see here that I have this notion of a gaming app, a leaderboard API, and a SQL database. And you see it in the build section over there that I define the context, and that's the build context. So where do I go if I do not have that container? And if I only specify an image, it will pull it from the registry. But if I specify a location where a Docker build file is available, then we'll just run a Docker build on that particular build file. And based on this, it will then create the SQL Server first, then the web API, and then the web app, because there is a dependency between those 3. Now, the cool thing is that I can even create multiple networks in my definition. So if I look here in my Docker Compose file, I can specify that I have something like a front-end network and a back-end network, both using a so-called bridge network, which means that containers can just talk to each other and not outside that particular bridge. And then you create these more or less networks, and you can have a container in multiple networks if you want. So for example, the gaming web app is in the front-end network and the back-end network, giving it more access to both sides of the world. And then I have the leaderboard API in the backend and the SQL database in the backend. So that's the way we can even create a network layout that more or less mimics what you will have in a production environment. Make sense? See some nods? Okay, good. So then we have the compose files, and you can perhaps imagine that you want to specify these services, but I might have something specific for development, specific for tests, specific for acceptance. So wouldn't it be cool if I could create these override files and then use both files to create a new file that will be the definition that we're using on that particular machine or environment? So what we can do is we can create these Docker compose files, and we create the base Docker compose file, which then contains the definition of your service, the image where it needs to get it, the dependency between the service and the network infrastructure that you would like to have. And then in the environmental override, what you do is you create port mappings, additional environment variables, perhaps even other additional dependencies that you might have because that's not on that particular environment available right away. And what you need to do is you need to then specify in the command line the first file that is the base file, and then the override which overwrites the standard value. And then you get a new compose file, and that's then being executed on your machine. So let me show you that in a demo. So I will go here. No, I will go here. I only have a few command prompts, so it's not too bad. Let me go here. CD. I have too many open. Let's do this. So let me show you first Visual Studio. So what I have here is just something that we all know and love, I think, which is the MVC Music Store. MVC Music Store is nothing more than the ASP.NET 3.0 music store sample that's available. I thought, why not just use something old to show that you can use it in all this new shiny stuff? Because you do not have to convert all your software all of a sudden to .NET Core and run it on Linux. No, you can just run it on Windows, just using Windows containers and just by specifying some of these Docker compose files. So what you can do is you can right-click on MVC Music Store if you would have a particular website in mind, then use Add. And if you go to Add, then there's this option after it waits and thinks for a while. It's a very complicated operation, so sorry for that. And it's a nice place to put it. But if we go here, then you see that Docker support is grayed out for me, but it has to do with the fact that it already sees and understands that I have a Docker Compose project in there, that the Docker files are already created. But what it will do is it will generate the Docker files for you to create such an image, and the Docker Compose files to compose up your solution, which is quite nice. Oh, and then you do not get the menu back. That's cool. Oh, interesting. Oh, no. It's just one of those days. Okay. Let's see what happens when I do this. Oh, seriously. Okay. That will mean that I will kill Visual Studio. I'm sorry for that. I did not anticipate an overlapping window. I'll go there. Start it again. So what I can do is, you saw that I have this notion of this compose file, and what I can do is I can go into that particular directory with my compose file in there. So that's the source MVC Music Store. Here you see that I have this command line docker compose -f the docker compose file, and then the compose file override, which overrides some of the settings that I already have. Let me go here, open this up, and then show you the YAML files, which then contain the definition for the music store. So what I did here is I created this Docker compose file, and here you see that I have an image defined with the name music store. The context is the MVC music store, so that's the location where my Docker file is located. And then you see that I specified the name of the Docker file, and I just have one local file there. The idea is that if I would use different environments, I could then specify an environment variable to specify where I would like to go if it comes to the database. And what I've done is in the DB context, the only thing I did is read from the environment variable named MVC Music Store entities. And the moment that's there, I will change the connection string to that. Okay? That means that in my web config, I do not need a configuration of where the database is. I can always provide it later using environment variable. Now, what I've done is I said, okay, then I have a Docker Compose override for my developers, and they can now run on their local machine something that's dependent on SQL Server, which has a connection string with the same password, and the password, I just punch it in on the local host. Of course, this is something you would not send to production because that's not a nice way to manage your secrets. But for us in development, we do not care about this stuff because it's harmless because it's just a container. We throw it away. It does nothing. Okay, but it helps me spin up this environment very fast. So if I just click here on Docker run, what it will do is it will run a Docker Compose for me, pass in those two files, start up those containers. Then what it will do is we'll get information back from the running containers. What is the IP address that's running on at the moment? And then once that has started, it will start up the browser for me, and that browser will then browse to that particular IP address. Now, at that point in time, we have a new SQL Server running, which has a new SA password, and we have then a web application running on a particular port. So it's now composing up my database. I can see that over here, by the way. So here you can see what it's doing. So the cool thing is you can see all those commands that are being executed. You can see the results of that as well. And you see that it's now creating the database, and then it's creating the actual web application. So if I would go here to the command line and then say docker ps, I should be seeing some of these things, right? So you see now that I have a SQL Server starting. I already had one, but now I have a new one. And you see that the music store is running here now as well. So if all is well and this thing finishes, you see now it's doing a Docker inspect. Now it's connecting to the website. And the first time this takes a little bit of time. But what happens is the second and the third run, it will be very fast because they keep the containers running all the time. And they created this little trick where all the files that I have locally are mapped into the container. So they have this notion of a volume mount. Then every file I change in my local machine will service in my container. So I'm actually running and testing inside my container and I have a very fast loop in terms of development. Well, of course, always when you are in front of an audience, this fails because it can. I think sometimes that Visual Studio is just a little bit scared of a larger audience, and then it needs to crap out. Unfortunately, I cannot show it to you, but just a couple of minutes ago when I was rehearsing this worked perfectly fine, as always, but you probably won't believe. Nevertheless, what I could do now is say, well, I know this Docker container is running, so this is a music store here, Docker inspect. I'm going to inspect this 6D container, then I know the IP address that's over here. I can copy that out, go here, go to my browser, go to that location, and if all's well, I should now see my Docker container running. Of course, it takes a little bit of time to spin up the NDC Music Store. What it has a database generator, so it will generate the entities for me inside the database. So that always takes a little bit of time to get started. Yeah, so the question is, normally in a classic application, we have web.config. And web.config, if I would bake that into the container, then it's immutable, right? I cannot change it in every environment. So what is the way to make that work inside containers? And the thing is that in .NET Framework 4.7.1, they created this new extension of a configuration builder. What we can do is we can set an override with a configuration builder on, for example, the connection string. It's just in your config, you just state configuration builder equals name of the builder. Then you can reference a particular type of builder that you would like, for example, an environment builder or a JSON builder or anything you'd like. And what it will do is it will then override the values that are in your web config at runtime. Okay, so that's a very nice way to do it. The only thing you need to do is then specify the name of the variable that needs to replace the connection string. Okay, and that's a way to easily swap out connection strings and app settings. App settings and connection strings are now handled by default using .NET Framework 4.7.1 and up. Okay. Yeah, so your remark is then I need to upgrade to a higher version of the .NET Framework. Yes, that is true. One of the things that with the .NET Framework is that it barely supports older versions. You need to be on, what is it, 4.6 and higher to have a supported version of .NET these days. So it's something to keep in mind that you need to move over all the time. These are minor versions, so they should be version compatible. But it's absolutely, you need to bring them forward all the time. I think that even the past few months is now even, what is it, .NET Framework 4.7.2 or 3 or 4 even already. So it's pretty fast in their new revision. But I agree that that might be sometimes a little bit of a hurdle, especially if you are still running on .NET Framework 2 whatever. But in that case, there's some bit rot happening already for a longer period of time. Yeah. Yeah, so you're running now on 3.5, and that would be a little bit of a hassle of bringing that forward. One of the things that you can do, and what I did not bring it forward to a new framework. I just added this database initializer here. So if I go back to my entities, the only thing I did is in the constructor of the entities, in the DB context, I swapped out the connection string. Yeah, and that's something you can do yourself, of course, and there's a little bit of code to make that happen, and then retrieve it from my environment. Yeah. But .NET 4.7.1 and up now provides this capability out of the box with an override in your web.config. But completely agree with the fact that your image is immutable, and that's some big difference that you need to be aware of. So all of a sudden, you're not able to swap out these config values in a web.config. It's just amazing. It even cannot do PowerPoint today. We just show a PowerPoint, please. I don't think that it will be too hard to do. Okay, there we are. Good. So we have containers on our local machine. We now know how to manage dependencies and create dependent containers in different networks using Docker Compose. Now, the question is, how do we move that forward to production? Because we're still on our local machine, and now I want to move to production, but production has some additional requirements. We might need to scale things out. We want to run, let's say, multiple web servers. And if we want to have multiple web servers, we not only need to have multiple web containers, but we also need to have a load balancer in front of that so it can distribute the load. Now, if I'm scaling out my web tier, I might also want to scale out my application tier with a load balancer in between. And perhaps I might even use multiple caches, Redis caches, something like that. So going to production means that now I need to have this capability of scaling my container. Now, I can do that very easily with Docker Compose. The next step is that I would like to run in a more resilient and fault-tolerant environment. Because what happens when my host would die here? My machine needs to reboot for what particular reason it needs to reboot. Then I cannot service my customers anymore. What I would like to do is I would like to scale this out and then say, okay, I have multiple nodes, multiple machines running that converge inside this notion of a cluster. And that cluster will then manage the placement of the containers. So instead of having one machine with all those containers, same as your local machine, we are now going to spread it out and load balance and have fault tolerance across those different machines. So I'm distributing my containers now out to those multiple nodes. It gives me much better scale, and it gives me much better failover capability. Because what happens the moment my host dies? The moment my host dies, we have something that can monitor the fact that the node is down, and based on that say, okay, I do now not have this web and API at the moment, but what I can do is I can schedule that on a different node, which is available in my cluster. So here is it where we start talking about orchestrators and schedulers. Okay, so we talked about Docker Compose, and now we have this notion of a Docker or a container orchestrator, and we have the notion of a scheduler that knows where to schedule a container once a container has died, or when the load might be too high on a particular node, and move the load to other machines so that you spread the actual compute resources being utilized as best as possible. Now, if we talk about cluster orchestrators, then we have this whole landscape of choices. This is where we get, for example, the notion of DCOS and Mesosphere. And that's particular for the Linux world. If you look at Docker containers on Windows and Linux, you can use Docker Swarm, or you can use Kubernetes. And if you want to run Linux containers or Windows containers, which are what we call stateful, then we can use, for example, Service Fabric, which is something that Microsoft built for their own Azure cloud and what they're using for many of the services they provide. Now, these cluster orchestrators provide all these things like load balancing, fault tolerance, placement constraints, auto roll-ups, rollbacks, automatic upgrades, self-healing, and all those cool things that we need in a production environment. But the question now is, when you start building out solutions with containers, which orchestrator to pick? And if we pick an orchestrator, where can we land that in terms of a service? Because do you want to manage your own clusters in your own data center? Or would you like to move such a workload to perhaps the cloud? Now, Microsoft provides here Azure Container Services as one of the solutions. And 3 quarters of a year back, when I submitted this session, we still were not sure where things were heading. But I can tell you that Azure Container Services provides this notion of Kubernetes, Docker Swarm, DCOS as the orchestrators. And what it is nothing more than a set of templates to stamp out a cluster for you with additional nodes that you can scale up and scale down, and it will converge to the cluster for you. But you need to manage it yourself. It's like a glorified IaaS solution. It stands out the IaaS solution for you, and after that, you need to manage it yourself. It is based on ARM templates, and you can either create it in the portal, or using AZ command line, or you can use what we call ACS engine, which is nothing more than an engine around generating the templates for you to be helpful to create such an environment. Now, this week, I've been to the Build Conference. I just flew in yesterday evening to Minnesota. And at the Build Conference, we had some conversations, for example, with Mark Rozinovich and others on, okay, where are things heading? And what we've seen is that ACS as a service, which is now part of Azure, will be deprecated in the future. And why will it be deprecated? Because it's nothing more than this set of templates. And the other thing that happened is that there was this war around the orchestrators. But if you see what is happening in that space, there is now a clear winner. Because what we see is that everybody is supporting Kubernetes. DCOS is supporting Kubernetes. Docker is supporting Kubernetes. Everybody is doing Kubernetes. So Microsoft has talked with all the other vendors and said, okay, if you want to have an IaaS solution on Azure, sure, go ahead. But those vendors are now responsible for managing those templates for the future. And there's nothing more like an ACS service because it doesn't make sense. It's nothing more than just rolling out ARM templates to create an infrastructure for you. Instead of that, and what you see is, by the way, that Kubernetes is the winner if it comes to, if you talk to everybody, what do you use as cluster orchestrator? Everybody talks about Kubernetes. But if you look at what is deployed in production at the moment, I think the Docker Swarm is predominantly available. So Docker Enterprise, with all their stuff around it, is at the moment, I think, much more used than Kubernetes in production. That said, probably things will move over to Kubernetes in the future, and we will see that Docker Swarm probably disappears. Not sure what will happen there. It's an interesting space to watch, and especially because Docker Swarm or Docker Enterprise is the bread and butter for Docker. So we will see where that will head as well, because where's their business model in the future. So for stateless services, Kubernetes makes total sense. But until you might have these specific workloads that you need to create that are stateful, where do you go? Well, you can try and make that work in Kubernetes, but for that we have Service Fabric. Service Fabric is built for stateful. It's where they built SQL Server on. It's what they built Cosmos DB on. It's what they built Service Bus on. So all these stateful services in Azure are built based on Azure Service Fabric. And that's something that will be there to stay for the longer future because Microsoft is building all their stuff on Service Fabric. Of course, we are going to use Kubernetes much, much more, but I think that this is more or less the state of the union as today. Now, everybody is asking, instead of having IaaS templates, isn't there a better way for us that we don't want to, because we don't want to manage the cluster all the time. We do not want to know how Kubernetes works. We just want to schedule some workload to it, make it distributed across nodes, spin up some additional nodes, converge it to the cluster, but I do not want to manage the cluster all the time. And this is where AKS comes in, which is Azure Kubernetes Services. And this is a fully managed Kubernetes service. You only pay for the worker nodes that is spinning up the virtual machines and running your workloads. And the upgrades to the later versions of Kubernetes are completely managed by this platform as a service infrastructure. So what you see is that in ACS is more or less now replaced with this notion of AKS, but there we now have only one orchestrator, which is then the Kubernetes orchestrator. Microsoft just announced last week also Service Fabric Mesh, which is, you might say, a serverless cluster for Service Fabric, meaning that it will spin up enough compute for you to move your workloads there, which is also fully managed. So those are two great solutions, I would say. If you want to do Kubernetes more in a serverless way, so you do not want to manage all those nodes, there is now this option of having what we call a virtual kubelet, which then connects Kubernetes to Azure Container Instances. What happens is that we all of a sudden get a node, and that node can schedule containers on ACI, and ACI can just spin up as many containers as you want and as much workload as you want. So you have more or less the option now to what we call burst new workloads into ACI using Kubernetes as the cluster orchestrator, which is kind of cool. Now, perhaps this drives a little bit too far, but this is more or less the whole ecosystem that you can now tap into, and AKS is there to stay for the future, you would say. Now, if you're working with a Kubernetes cluster, then instead of using Docker and Docker Compose, which you would use on a Swarm cluster, we are now going to use Coop control. And Coop control helps me create this notion of deployments, helps me create exposing services to the outside world, and helps me doing what we call a zero downtime upgrade of those containers being scheduled inside that cluster. So let me show you just by using the command line on how that looks, what that looks like. So what I will do is I will go here, and as you've seen, I have here my repository, and I can go here to Container Services. And what I have here is I have my NDC cluster running. This is still an ACS cluster, and the reason I'm using an ACS cluster is because this supports Windows nodes. AKS does not yet. It does when you have the virtual kubelet and go out to ACI. But at the Windows containers are in private preview at the moment. Since I have this ASP.NET container, which I would like to schedule, that's the reason I'm now using this. So let me go here and then do some command line. So CLS, and I can do Coop, CT, Coop control, Coop, CTL, and then, for example, get nodes. And here I get information on the number of nodes that are running in my cluster. And what I can do is I am already running the proxy, so I can show you here that I have Kubernetes running. And Kubernetes has this dashboard where you can see the deployments that are there. And you see that in the default namespace, there's no deployment at the moment. And what I can do is I can do something like this. Kube CTL, create deployment. I will call that IIS. And this deployment will then use an image called Microsoft/IIS. And now I'm creating this deployment and would like to expose IIS to the outer world. So now what I can do is say Kube CTL, expose, deployment. I want to expose the deployment IIS. I want to do that on port 80. And I want to do that on the outer load balancer so that everybody can access that particular website. So I can now say type equals load balancer, and it will create the service. And now when I go here and refresh this, I should be able to see that IIS is now running on my machine here. That IIS is in a so-called replica set. It has to do with the fact that if I want to have multiple instances, it will guarantee that there are at least so many instances running in the cluster, so I can have load balancing in front of that, which is already automatically taken care of for me. And what we see is that we have a service that is currently being configured. And this service is now being configured on the Azure load balancer, so it gets an endpoint there where I can then tap into just from the interweb. So we need to have a little bit of patience, and then we should be able to see this IIS thing coming up, and then we get an external IP address, and with that, all of a sudden I can then go to IIS. Now the other thing I can do is, because I now have one instance running on one node, I would like to create failover and some more scale. So what I can do is kubectl scale deployment IIS number of replicas equals, let's say, 5. And now it will scale up IIS for me on the different nodes. So if I go to the deployment, you'll see that it's now in a transient state because it's scaling up across those different nodes. And when I look at the replica sets behind this, then you will see that I have some additional pods. You see this one was already scheduled and available, so I'm already servicing IIS, but I'm now scaling out, having multiple of these containers running on multiple nodes. Now you see the service is now available, so I should be able to go here and see IIS running. And when I F5 this will be just round robin, going through the different nodes or the different pods that are scheduled. And that's the way I can very easily scale out my workloads on Kubernetes. Make sense? Question? Yeah. Yeah. So your question has more to do with the state that's in that particular session that you have with your user. And the thing is that the question is more or less, can I preserve that while I'm scaling up or scaling down, or doing a zero downtime deployment? And the answer is yes. The Kubernetes environment will take care of that. So it will know that you have an active connection with that. And what it will do is it will then scale up new ones and phase out the other ones the moment there's no traffic anymore. Okay? So that way you get zero downtime deployment. One of the things, of course, is your application needs to be able to handle state in a different way than just keeping it on the local machine. So keeping it in memory is not a good idea. You always need to keep it in a Redis cache or something like that, where you have a distribution session, for example, that you can share with each other. So you always need to manage state in a different way. The whole notion of Kubernetes is that it's a stateless orchestrator. So it does not keep state of a particular machine, but it's the connection that you have will be served until it's done. So if you do a request, you get a reply back, and it will not accept new requests. Those will go to another node. Make sense? So it's not really preserving the state, but it will not terminate your connections which you have for a particular request. That's perhaps a better way of answering. So then the final part is, how do I get this stuff into production? Because if I go to production, then I want to have this notion of a continuous delivery pipeline. Because that's the way I want to commit my code, which I have running in, for example, Visual Studio or Visual Studio Code, committed to my Git repository, preferably using pull requests so I can enforce a 4-eyes principle in the changes that I'm making, and then move that into a bakery, something where you build or bake your containers, push them up to your registry of choice, and from that moment on, then deploy them to a particular cluster, node, or environment, or namespace, or whatever you pick. Of course, you want this to be secure and compliant by default. And making that happen is extremely easy these days when using VSTS. So I would like to close out with the final demo here. And what I have here is, you notice that I have the NVC Music Store here. What I will do is I will make a little change here to my application in the views, and I go to shared layout. What I will do here is I will make a change, something like hello NDC. I will save this change, and I will commit this. No, I won't. I don't want to undo it. I want to commit it, please. Live demo. At all. I'm going to sync that up to my Git repository, and then I'm going to show you what's going on. So this is now syncing my current local branch with VSTS. So that's successful. And what I have running here is the NVC Music Store. So what I have is I have here a definition of what I'm going to deploy on my Kubernetes cluster. I just did it by hand, but you can create these YAML files. And in this YAML file, I'm specifying that I have a service. And that service exposes an app MVC Music Store. That app MVC Music Store is over here defined. Okay. So here you see that I have the app MVC Music Store. It's using the image coming from my registry, which is the NDC ACR that I just showed you in the Azure portal. And what you see is that I have these placeholders there, dot build ID underscore, that gives me the unique identifiers of that particular container that I created. Never use latest, that's very dangerous. Shooting yourself in the foot. Always use unique identifiers to identify the container that you created. And here you see that I'm passing it into the environment the connection string. Now, be careful here. This is just for demo purposes. If you're moving connection strings to your node cluster, use Kubernetes secrets and use Azure Key Vault to get the secrets in there. Okay. But for this demo purpose, it's easy to show you how we can do it. But it's important to understand. So this is the code which is just checked in to my Git repository on VSTS. And what I've done is I have on that thing a build. You see it's already done. It created this new instance over there. So if I go here to this build and look at that build definition, then the only thing that I'm doing is I am building my NVC Music Store and then moving that into a container. So just a couple of steps. I'm just restoring my NuGet packages, build the solution, then build the container based on my YAML files, and then I push this to the registry, the Azure Container Registry NDC ACR that I have. Now this pushes it to the container, and then once this is done, we will see that if I go to my cluster. To my ACR registry over here, you will see that if I go to the repositories and the NVC Music Store, that I have a newer version, version 40, what is it, 50, 64, 70. Well, you see it's moving up the stack. So we got newer versions there all the time. And this one is then picked up by a release definition that I have. So I have here the NDC release definition, which is also automatically triggered the moment I get a new image. I can either pick that I will trigger this from my container registry, or in this particular case, I selected that it's been continuous deployment triggered based on my builds that I did. And what I'm doing here is I deploy to a development environment. So here I replace the tokens that I have in my YAML file based on the variables that I have. So here you see the connection strings for development and production that I can use. So I can use multiple databases. And when I go back to the pipeline, you see that I have these tasks here, Coop control apply, which applies that particular file. Now, while I've been talking here, I should be able to see my releases. And if all is well, you see that I have a release of 2 minutes ago. And when I go to my cluster over here, and I go to, let's say, the development workspace that I have, you see that I have nothing here. There it is. You see it over here. And when I go to that endpoint, we should be able to see now that we have a new instance running of my ASP.NET Music Store which now has the annotation that I just created in the layout file. So this gives you then the full end-to-end experience of checking something into version control, having, of course, a pull request of something like that to actually guarantee your 4 eyes principle in there. And here you see hello NDC now showing up on my cluster. First into a development environment, which I just created namespaces on that same cluster. But I also can move this then gradually to another namespace, which is then the production namespace. And here I have another endpoint where I then have my other ASP.NET MVC Music Store running with the production code. And I can make additional stages in between to do some UI testing and other stuff to additional validate these things. One final cool thing to show you is that if you look at this release path that we have here, so I go here to edit, I can set deployment conditions here, and I can set that I would like to have a deployment gate, either approve it by somebody as a person, or have an automatic gate. And here I can select, for example, Azure Monitoring Alerts, and here I can select Application Insight. So if I have Application Insights telemetry, then I can wait here based on alerts that I set, that I want to wait for, let's say, 15 minutes or 20 minutes, see that there is still load on that environment, and then see that there are no errors. So I can use, for example, Traffic Manager to get 10% of the traffic going to my new deployment slot that I have. Based on that, make a decision if I want to go forward to production, yes or no. So this gives me the full capability of going from a check-in even into production. And the cool thing is, if I look at the release which is just done, if I go to the releases over here, leave that, then I can track this release completely because I can see exactly what has changed. So I can see that there was a continuous deployment requested by Marcel. This is the change, this is the change, or this is the build. If I go to the build, I can then track that down and see, okay, so this was the build that succeeded, but what was the change? Oh, this was authored by Marcel. And if there's a pull request in there, I can see that the pull request has been reviewed by someone else, give me the 4 eyes principle, hence compliance in most of the situations. So if you want to be SOX compliant and all those things, it's been handled by this. So that should give you a fair understanding on how this works. With that, I would close it out. Wrapping it up, I hope you learned a little bit more about Docker and how we can adopt containers for development and production, that we use Azure Kubernetes Services now instead of ACS with the other orchestrators, fully managed PaaS solution. And VSTS is a very easy way of getting this stuff into production in a secure and compliant way. Now, if you would like to learn more of this stuff, I'm also a Pluralsight author in the evening hours. So you might want to have a look at one of the courses that I have there, which go a little bit deeper into those specific details. But I go in, for example, completely on the Kubernetes side or even on the Service Fabric side on how you make this stuff work. My name is Marcel de Vries. I'm a CTO at Xperiot. Thank you so much for listening to this. I hope you enjoyed it. I brought some magazines with me, which you might want to read. It's just technical magazines where we write and share our knowledge just because we can. We like to do it. And I would like to thank some of the people that made this presentation also possible, because some of the stuff I just used from open source, some of my colleagues, images come from unsplash.com and Gliffy. So that's in terms of attribution to open source things. Are you in for perhaps a little game? Because what I did is I prepared a little game for you guys, if you like it, but I'm running over a little bit in terms of time. But what I have here is if you play the game, then you can win a nice t-shirt, if you like it or not. The t-shirt of getting epic shit done. So if you like it, what I will do is I will start this, this classic Kahoot. What you can do is if you pick up your mobile devices or anything like that and go to kahoot.io, then you can log in with this pin. Let me see if some of the players are coming in. I brought pretty nice stack of shirts, so Should be enough for most of you. I hope you all have Wi-Fi. See if we can get you in there. Okay. Yeah, there we are. The mystery badger. So one of the things I did is I let it generate random names, because the last time I did it, I got some interesting names on the screen that I didn't want to have on a recording. Does it work, or is it not helping out? Okay, so we've got 2 contesters. That's good. Anybody else? There we go. Okay. So who did not get in and wants to get in? One more? Okay. The Amazing Goose. Is that correct? Okay, there we go. Okay, cool. So let's get started. Some simple questions that I have for all of you. So where do container images come from? And you've got the option, they are pre-installed on your machine. They come from a public or private registry. They come from Docker Hub, or they come from Microsoft. Which is the correct answer? And by the way, speed also counts towards points. Okay, cool. So we got 8 people that had that answer right. So that's awesome. And we have the Nimble Finch. Who's that? Nimble Finch. So you're doing good. So looking good for a t-shirt. So the second question, since I'm Dutch, I thought to just ask the question, what do Dutch people drink in terms of beer in the Netherlands? Heineken, Krols, anything but Heineken? Or they just hate beer? The reason I'm asking is because we are a trade nation. We just create beer to export it to other countries. So if you enjoy Heineken, we do not. At least I do not, and my friends also. If I would serve them Heineken at a party, then I would probably never see my friends. But I didn't add points for this one. Just so how do you scale your containers on your local machine? Use the Docker Compose up scale, or use Docker Compose scale command. Use Docker scale, or use Coop control scale. That one is a little bit more complicated, but we need to, of course, weed out so that we ensure that people are actually winning. Nice distribution, that's good. So the thing is that you use the Docker Compose up command with --scale. In the past, it was Docker Compose scale. That was an older command, but it's deprecated and not being used anymore. So I got 2 more questions. What does a container orchestrator provide you? A location to get your images from, fault tolerance, load distribution, 0 downtime deployments, a nice debate at work, which one is the best, or more things to learn. And we got many people having the correct answer. So Nimble Fit, you're still up the stack. That's good. And the final one I have, what did you think of this session? I mean, that's an interesting question to ask. So awesome, give me a t-shirt. I have okay, but can I still have the t-shirt? Moi, I probably won't get a t-shirt. Or, dude, this was terrible. Boo, boo, boo. But can I please get a t-shirt anyway? Well, thank you so much. That's very nice and polite of you. Probably everybody wants a t-shirt nevertheless, but that's kind of cool. So that was it in terms of the questions. So I have 3 winners here, the Gentle Octopus, the Nimble Fish, and the Diplomat Mouse. If you can please come up to the podium later, then I have a nice t-shirt for you to come and pick up. Thank you for your attention. Hope you enjoyed it, and hope to see you next time.